Now that we at least have this sort of vague idea of what a control system is, let's take a look at a couple examples. So I think the easiest example to sort of help demonstrate what we're talking about is an elevator. And so in terms of what we talked about in the previous videos, inputs, outputs, specified performance, let's talk about what our elevator is doing. So our input to our elevator is just going to be some push button, which is our desired floor. So you get in an elevator and you push floor number 4 and you expect the elevator to go to floor 4. So push button for some desired floor. And then of course our output is just going to be our elevator location. So let's consider sort of the relationship between these two things graphically. Okay, so let's say over here on our vertical axis we have our elevator position. And so let's just say the units of this is our floor. So for example, let's say down here we're at sort of our lobby. Let's say that's 1, 2, 3, floor 4, and floor 5, and so on. And on our horizontal axis, let's say that this is time. And we don't necessarily even need to specify units, but let's say we're interested in sort of 2 instances in time. So let's say we get in the elevator and then at some time, T1, we push a button to take us from floor 1 to floor 4. So what that's going to look like is initially we're down here at floor 1, and then at time T1 we say we want to go to floor 4, so we've pushed that button. So this is what our input curve is looking like. So here's our input. So initially nothing had been pressed, and then we say we want to go to floor 4. So now what does our output look like? Of course, our elevator position doesn't instantly jump up to floor 4 like that, but rather it's going to be slowly moving from floor 1. So of course it's not going to be doing anything until it gets this input signal. Once it gets this input signal, it's going to start moving towards floor 4, and eventually it's going to get pretty close. And it might not get all the way there. Of course, we're going to talk about different ways to characterize this, but for now let's just say it might not reach exactly where we want it to. Okay, so let me label a key time here as well. So let's say once it's got here to where it's not really changing much as we go more as we give it more time, let's say this is some arbitrary time T2. So let's talk about some key ways that we can sort of describe the performance of this elevator system. So we want to describe our performance. So this is sort of that third feature that I had highlighted in our definition in the previous video. So we have a specified input that corresponds to a desired output, and we want it to be within some specification. Our performance needs to perform in a certain way. So to describe our performance, we have a couple important things. First of all, we have what's called our transient response. And these are both things that we're going to come back to and we're going to hit on a lot harder in later chapters. But our transient response is very important. And so in the plot above, this is what's happening between T1 and T2. And you might have heard some different terms for different types of transient responses in other classes. And again, we're going to come back to these a little later on in the semester. But just to sort of throw these names out now, this transient response can be critically damped, overdamped, or underdamped. And so again, we'll come back to that later, but it's basically just describing the behavior of this curve in this transient region. So the other main thing that we want to sort of note when we're describing the performance of this system is our steady state error. And so in this case, our steady state error is going to be the difference in position for our input and our difference in our input, which is our desired position, and our actual output in the steady state. So let's just say this is our difference between our input, which remember our input was our desired output, and our actual output. in, of course, steady state because it's steady state air. So if we come back up here to the plot, I think it's a little easier to see here, but in this case we don't really have much, but it would be this little region here. So this would be our steady state air. So we have something that looks like that. Okay, so those are both key metrics, and we're going to come back and we're going to talk about those a lot more later on. We'll spend about a chapter on each of those actually. But hopefully this gives you a little bit better idea of sort of what's going on. Just to sort of briefly mention some other control systems. We're not going to go through these in as much detail, but some other control systems would be, for instance, guidance, navigation, and controls of missiles, aircraft, and spacecraft. So a lot of these things move in such sophisticated ways that humans can't control them directly, so we have to have some type of control system interface that's able to control them accurately. So missiles, spacecraft, aircraft. So of course we see here a lot of overlap with, for instance, aerospace engineering. Another big area of control systems engineering is process control. So process control, so this is something that would be done a lot at a company like Eastman. So we're monitoring and controlling levels of, for instance, liquids in certain tanks, or maybe we're monitoring and controlling concentrations of certain chemicals during certain processes. We could also be talking about monitoring and controlling thickness of some output, whether it's paper or sheet metal. Anything like this is going to fall under this process control sort of sub area of control systems. And then of course, another sort of simple system to comprehend, similar to our elevator example, is one that we mentioned in the previous video, which is just our home heating system. Okay, so hopefully that has helped sort of help you understand a little better what a control system is, what's the input, what's the output, how do we sort of characterize the performance. And what we're going to do in the following videos is sort of keep building on this and keep defining things a little more specifically until we have a better picture, and then we'll get into some actual stuff in some later chapters.